So, hello everyone, and welcome to this weekly session that we conduct, Ask AuxEn Anything. And this is an online platform for the civil structural engineers to interact with us and ask their doubts or queries that they may have related to any steel or RCC design concept or any project that they are doing or construction site issues. So, we conduct this episode every Sunday morning, and this is the 61st such episode that we are conducting. So let us begin by taking the queries that have been put. First, we will take the queries from the Google form, then we will take the queries from email, and then we will take the queries from live audience. So let us start, and I'll share my screen. I hope my voice is audible. So the first question has been asked by just a minute. First question has been asked by Engineer Anshuman Adhikari. He is from Guwahati, Assam, and he is a working professional and an independent consultant. So he is asking this query, and he has also put one image for this. So let me just share that image as well. Image. I'm not able to get that image. Image. Okay. Never mind. We will. I have a general sense of what he's asking. So let us try to take that question. I'll draw the image over here itself. So what he's saying basically is that if I have a beam like this, okay, I'm trying to draw an isometric view, and this beam is, let's say, connected to some column flange. Now this beam is resisting certain shear force which is acting downwards, okay, and the beam length is in this direction. This is how the beam is oriented. Are you able to imagine this beam? So the question being asked is that for this shear, if I have put weld over here on the flanges, then I have put the weld on this web, and then again I have put the weld on the flanges. So generally our code classifies two types of uh, welds on the basis of their design action. So one are called as the uh, Q stresses, or the welds having Q stresses. That is uh, that is when the force is in the plane of the weld. Please understand. Okay, plane of weld length, and then there is an F stress where the force is perpendicular to the plane of weld. So code defines the two types of weld stresses on the basis of the forces acting in them. One are called as Q stresses. So the force has to be in the plane of the weld length, and then other is F, where the force is perpendicular to the plane of the weld length. So if I talk about the welds over here, which are connected to or which are provided to the web, so the shear force that is acting, this is in the plane of the weld. Yes or no? The plane, the plane of the weld. Are you able to imagine? If I am putting, how do I explain? I think you are able to understand. In fact, this is the plane. If I were to draw, this is the plane, in plane. If I were to draw perpendicular, it would be something like this. So if the forces were perpendicular to the plane of the weld, it would be like this. But right now, the weld that I have drawn, which is connected to the web, the shear force V that will be acting, let's say V is acting like this, it is acting in the plane of the web, sorry, in the plane of the weld length. So that's why we will call it as the Q stress. We will say that the for this weld, the stresses will be Q stresses. Now for the welds connected to the flange, this is where the confusion is. Please understand that the weld length is like this, but the stresses are not defined whether they are perpendicular to the weld length or not. The stresses are defined whether they are perpendicular to the plane of weld length or not. So if this is my weld length, it lies in which plane? Again, like it lies in this same plane. Do you agree? This weld length also lies in the same plane. So again, once again, if you see the shear force that is acting, again it is acting in the plane of the weld length. So that's why the welds which are connected to flanges, for this also we will call them as the Q stresses. And for this bottom flange also, the welds will be called as subjected to Q stresses. So understand this point clearly, that the Q and F are classified or differentiated on the basis of whether they are in plane or out of plane. It's not whether they are along the weld length or perpendicular to weld length. No, it is defined on the basis of whether they are in the same plane as the weld or they are perpendicular to the plane. So if I had a moment acting and if the moment was creating some T and C tension compression, then you would say that this T is creating F stress in the weld, because now this F stress is perpendicular to the plane in which you have got the weld. So then it would be called as the F stress. Understood? Okay. So I hope this uh, response is clear. So this was Engineer Anshuman Adhikari. Then we have next question from Engineer Suraj Gupta. He's from Gurgaon and he is a working professional. Uh, so he's asking, please explain steel plate with shear stud embedded RCC beam, coupling beam for shear design with references. So are there two different questions or what? Please explain steel plate with shear studs embed RC beam, coupling beam for shear design. I think he is asking that this question has been asked before also, although I don't have a ready answer for this because I have not done it myself. So what he is saying is that he has seen that in beams they embed a plate like this, steel plate, inside the beam. So what is the role of this beam? What is the role of this steel plate? So this steel plate is to steel plate embedded in RCC beam. So if I were to draw a sectional view, let's say this is my B, this is my D, and if I were to draw a sectional view, it would look, my section would look like this, that this is B, this is D, and then there is a steel plate like this. Now the reasoning for providing this steel plate is that it is going to take shear. So to take shear, this type of steel plate is provided. So the question being asked is, explain this type of an arrangement and why is it used for coupling beams, because coupling beams are usually subjected to very high shear forces, and then you may not be able to uh, manage the shear with the coupling beam sizes that we have. So this kind of an arrangement is provided. So he's asking about the design of this. So I'm not very sure that how this design is carried out, or what is the logic that they uh, incorporate, or what is the logic that is applied for this design. One simple way could be that whatever, let's say, at d distance, whatever is the shear acting, okay, so for that shear force, maybe you could find out the shear that will be taken by this plate, and that you could find out by, let's say, Fy upon root 3 gamma m naught in AV. Okay, so where AV could be this depth into this thickness, that can be, I think, one of the way to do it. However, I have not done this type of calculation before, so I don't know how they do this. And then when how much VC they assume, or how much shear concrete will resist, what is the value that they assume for that, all those things I'm not sure about it right now, so I'm not able to comment fully on this case. Do you have any calculation, Mr. Rohit is asking, for the design of shear studs in RC beam that can be used for coupling beams? No, I'm not sure. Where do you provide shear studs in the coupling beams? Where do you provide shear studs in coupling beams? I'm not sure at how or why the shear studs are provided. If you could provide some sketch for it. Mr. Rohit is asking, I think, for the earlier explanation, if the welding is done on flanges also, then will it not have moment, as it will act as a moment connection? So the moment will cause tension compression, causing F stresses. Right now, we are talking about pure shear. If it's a case of pure shear, this beam is subjected to pure shears only, no moments. We discussed that particular case. I did not discuss about movements. Movements I then later explained. Yeah. Okay. So for the steel embedded plates, I'm not sure right now how do they do the calculations. This can be one of the ways in which you can calculate the shear resisted by the plate, but I don't know. I also need to study. So this was the query by Engineer Suraj. Then we have a query from Engineer Rohit Kashyap. He's from Guwahati and he's a working professional. So he's saying, oh, he's saying a lot. What he's saying. For a G plus 2, for a building of G plus 2 to G plus 6 approx, column systems are generally economical theoretically. But if we use the Codal time period formula for other buildings, it comes to 0.5 to 0.5, 0.4 to 0.5 seconds. When I model the building in ETABS, the time period comes as 2 seconds. Now the ETABS has calculated time period as per stiffness of the structure. While using the Codal formula to get the base shear in ETABS, the base shear will be very high. So the columns have very high reinforcement, which is uneconomical. So can we use the mode 1 time period of ETABS for design? For buildings with importance equal to 1, we can use other buildings time period. But if importance factor of 1.5 for institutional buildings, we have to use shear walls in the buildings. No, so the short answer is no. The code does not allow you to use the time period as per computer models. ASCE 7 allows you to do that. ASCE 7 allows you to do that. But then remember that the Indian code does not allow you. So as of now, you are forced to take the codal time period formula only. Also remember that when you are modeling these buildings, you are ignoring the stiffnesses that will be provided by the block walls, isn't it? You have not modeled the brick walls, so you have been ignoring the stiffnesses provided by the block walls. So you are just making a bare frame structure, and that bare frame structure will be quite flexible, and that is why you are getting time periods of, let's say, 2 seconds, whereas the codal time period was zero point 0.5 seconds. So the codal time period assumes the presence of brick walls, and then it adds a certain stiffness, and that's why you get stiffer time periods. Obviously, stiffer time periods mean that you will be using higher base shears, and you have to design your system accordingly. So forget uneconomical, economical. It is what your code says, and that is what you are supposed to follow right now. Okay. So you are not supposed to, or you're not allowed to use any computer time periods. ASCE 7 allows you certain conditions. I think if your time period is more than 1.4 times the modal time period, I think then you have to use the modal time period. If not, then you are allowed to use the computer model time period. I think such conditions are there in the ASCE 7. He is saying, so can we use dynamic time period, and how do I calculate the dynamic time period? No, dynamic time period means you will calculate the, or you will, there's nothing like dynamic time period. You do a response spectrum analysis, and in response spectrum analysis, you consider the presence of all the modes of vibration, accordingly calculate the base shear. But then remember, you are still required to do the base shear scaling. So base shear scaling for response spectrum analysis is anyway required by the code. All right. Okay. Then his second question is, how do I scale up the vertical EQ spectral acceleration Z? Vertical acceleration spec Z. I don't think there is any scaling up that is mentioned for this, because we, how will you calculate? I mean, we don't have any seismic. Uh, we don't have any. How will you get the response spectrum in Z direction? I'm not sure about the scaling that you can do, or how to do the scaling, if at all scaling is required or not. I am not sure at this point that whether you are required to scale up the uh, shear corresponding to, let's say, the vertical EQ in Z direction. So uh, I'm not sure about this question, this answer rather. While creating the function for spec Z, we use the 1893-2016 and then click user defined, and for 0 to 10 we give a value. What value should be? So you calculate the value as per, I think, two-thirds of AH. So simple, what you do is AH is your Z upon 2 into SA by G into I by R. So you calculate the AH, and then corresponding to your AH, you calculate two-thirds of AH. That will give you the AV. So you put, when you are defining that table in the ETABS, let's say, and when you are defining user defined response spectrum, then you give for time periods value. So you define, let's say, from 0 to 1, maybe go up till 6, 7, 8, 9, 10 seconds. Give the same value of AV everywhere, which will be equal to two-thirds of AH. So keep putting the same value in all the, corresponding to all the time periods, and define up till long time period TL value. So I think the TL value in the 1893 is given as 6 seconds, I think. So go on defining till 6 seconds, and for every value put the value equal to 2/3 of AH. Okay. So put a constant value for each time period varying from 0 to the long time period formula value. The second, okay, so this was Engineer Rohit Kashyap. Then we have the next query from Engineer Manish Kumar Pandey. He is a working professional from Ranchi, and what he is asking: while designing RCC structural walls with boundary elements, we calculate the moment taken by boundary elements to be this, where Mn is the moment capacity of the web and Mu33 is the design moment. This Mn is calculated by using annexure A, but that is not allowed as per clause this. The other option left is to provide web with minimum reinforcement and apply entire moment to boundary elements to form the couple. In this case, capacity of web will be ignored. How to calculate the moment capacity of the web in later case and design BE for MU. So see what your code is trying to tell you, that the annexure A of IS 1893 has been provided to you for a reinforcement distribution like this. That is the core concept that you need to understand. So this is how the reinforcement is distributed uniformly about the minor axis, and you don't have any reinforcement distribution, let's say, about the major axis, you do not have any column like reinforcement distribution. So your reinforcement distribution is about the minor axis as shown. Now, if you have a boundary element, boundary element, generally what we do, we provide a certain different arrangement of reinforcement, let's say like columns. So now for this type of a cross section, you may not be able to use the annexure A of IS 13920, because annexure A has been developed only for the reinforcement when it is uniformly distributed about the minor axis, and not for reinforcement arrangements like this. So what you can do very simply is, let's say this was your entire length of the wall. I don't have the values, but let's say it was 4 meters and this was 300, and then you were putting this equal to maybe 600 and 600. So what you can simply do is that for the web portion, you calculate the M web. For M web, you consider the dimensions only from here to here. So what you do, this dimension will be how much? 4 meters minus 1200. So 2800 and 300. So for moment capacity of the web, only consider a cross section of 300 into 2800. Now for this section, you will appreciate that the reinforcement arrangement is symmetric about the minor axis, isn't it? It is like this, equally distributed on two faces about the minor axis, equally distributed about the two faces about the minor axis. So you use annexure A for this. You use annexure A. Using annexure A of IS 13920 and taking these dimensions, you calculate the moment capacity of the web, of course, corresponding to the axial load being resisted by the web. To calculate the axial load being resisted by the web, you can just use the proportionality thing, proportional to the uh, proportional to your areas of web and areas of boundary element. So once you have this, then you have the total moment. Let's say mu, you do minus m web, you will get the moment that will have to be taken by boundary element. For boundary element, we assume c and t. So you divide it by x, you will get the c or t due to the moments, and then you will add it to the compression for vertical compression due to uh, gravity loads or the effects of earthquake. So you take that and then find out the net forces in boundary element and do the design after that. Okay. So short answer to your question is that when you want to calculate the m web, you just consider the web dimension only, and then use the annexure A to calculate the moment capacity of the web. Okay. Mr. Rohit is asking, for AV, can we use SA by G as 2.5? You may, if you want to be on the conservative side, you may use SA by G as 2.5. Okay, so this was Engineer Manish with his query. Then we move on to the next question. So these are next set of questions asked by Engineer Rishabh Thakre. He is from Mumbai and he is a working professional. He is asking, shall we check irregularity in structure for service combinations or strength combinations? But vertical irregularities, whether they are horizontal or vertical, they are more to do with the configuration. How do combinations come into this? I mean, for any combination you check, it shall come out to be a irregularity, isn't it? Whether it's a torsional irregularity or mass irregularity or whatever is the irregularity, it will come out to be uh, irregular, whatever load combination you use. If you have any doubt, use the strength combinations. Uh, Use the strength combinations, and in the strength combinations, you may check. I think even if you don't make combinations, just check for the EQ loads. That is also enough. Just check for the load cases. Why even to check for combinations? Check for EQ load. I think that is more than sufficient. Yeah. So check for load cases only. I think that should serve your purpose. Uh, his next query is Engineer Rishabh is asking, if as per IS 1893, if there is a mass irregularity and strength irregularity, what do we do? So the corrective actions to be taken are given in the corresponding table number 5 and 6. Whether it's an horizontal, whether it's a horizontal irregularity or vertical irregularity, the way of application is sorry, the way to take care of the irregularity or how to deal with that irregularity is already given quite well in the code. His next question is how to check for torsional irregularity. Same, you study the code, they have given you proper steps on how to check the irregularity and what to do when the uh, when the irregularities exceed the limits given in table 5 and 6. So you go through table 5, table 6 of IS 1893 part 1 2016, and also read the amendments that have been issued, amendments 1 and amendment 2, because there have been some changes made to table 5 and table 6 in these two amendments. So you go to amendment 1, 2, and you go to the main code and study how the irregularities have to be checked and what is their final resolution given. So in most of the cases, you will require to be doing the response spectrum analysis. In one of the cases, you shall be required to, in couple of cases, you are required to reconfigure your structure. Okay. Engineer Rishabh Thakre is further asking how to analyze vertical how to analyze for vertical seismic acceleration and application ETABs. Is it mandatory to apply vertical acceleration to all cantilever parts? You go through the code, they have told you for which type of cantilevers you are required to or supposed to assign the vertical acceleration and check for it. Study IS 1893 part 1. They have clearly defined. And how to apply. So as I was telling you, you define a spec, let's say spec Z in ETABs, and uh, so it will be defined as a response spectrum function. Now in the response spectrum function, you find out the AV as 2/3 of AH, AH you find out as Z upon 2 into SA by G into I by R. So you know the AV. Now while assigning this, make a response spectrum function and give the time period and go to user defined response spectrum function, time period and the value of the acceleration parameter. So for any time period from 0 to TL, you go on defining the same AV. So it's as if we are defining a constant AV irrespective of the time period. So go on defining this. This is how you will get your spec Z, and then use this in, let's say, a response spectrum definition. Define a RSZ, let's say, and use this spectral acceleration definition in that, and then incorporate it into the load combinations. So this is how you can do. There are some good YouTube videos available for this. You may uh, go to YouTube and watch those few videos and understand. Then the next query is from Rajendra Kamre. He is from Sangli and he is a working professional. He is asking, please explain the terms like liquefaction and swelling pressure. See, liquefaction is, it means that whether your soil has a tendency to liquefy or soil has a tendency to lose its shear strength under the effects of under the effect of seismic loads or under the effects of earthquake. So does your soil have a tendency to lose its shear strength under the effect of earthquake? That is what is called as liquefaction. So what that means is that if you have your soil strata like this, and suppose you have kept your footing over here, and and this strata on which your footing was kept, this has a tendency to liquefy. So if it has a tendency to liquefy, what will happen? That it will under the or at in an event of seismic load, or in an event of earthquake, this footing will not be able to, this strata will not be able to provide any bearing capacity or provide resist any bearing pressure. Do you understand? So what will happen, that this footing will collapse. Collapse means because the soil is not able to support it, the footing will no longer be able to resist the column loads. So liquefaction is what we need to avoid. So generally the geotechnical reports that we get, they tell us about the different soil stratas and they tell us about the possibility of liquefaction. So what we generally do, if there are zones or if there's a strata which has a tendency to liquefy, I shall not place my footing or at that level, and I will take it to a deeper strata where there are no chances or tendencies of liquefaction. So let's say this strata does not liquefy, then you would like to keep your footing on this strata. So this is what is meant by liquefaction. Your second term that you asked was swelling pressures. Swelling pressures are basically in expansive soils. In expansive soils, what may happen, that when they come in contact with water, the volume of those soils tend to increase, and if the volume of soil tends to increase, what will happen, the soil will exert an uplift pressure on the footing. So this usually happens in expansive soils. Now the expansive soils are mostly, if you see, black cotton soils are your expansive soils. So you have to be really careful when you are providing footings in black cotton soil, that there will be a problem of uh, swelling, and if there is a problem of swelling, it may create issues with your foundations. So you need to either you need to go or remove the expansive soil layer and go below it, or some people try to stabilize your soil, lime stabilization, especially in black cotton soils, so that swelling is not uh, a major action. So these kinds of things you have to do, especially in BC soils, black cotton soils, because they are expansive in nature and they apply large swelling pressures. So the swelling pressures can be as high as around uh, 2 tons per square meter. The swelling pressure can be as high as 2 tons per square meter, means 20 kilonewton per square meter pressure can act due to the swelling. Then his next question is, what are the important checks for ring wall foundation? Please suggest good references for ring wall foundations. So for ring wall, I mean the important checks are only the same. That is the bearing pressure check, flexure, or even before flexure, the one-way shear, two-way shear, and flexure. So I think these are the normal checks that you have to do. There's nothing specialized or nothing uh, out of the ordinary that you do for your normal footings that you are required to do for ring wall foundation. Just the normal usual checks: settlement, bearing pressure, uh, one-way shear, two-way shear if applicable, and flexure. Okay, so this was Engineer Rajendra's query. The next query is from Engineer Vineet Kumar. He is asking, in oblique connections, acute and obtuse, beam and beam to column, how should the connection be done? I think what he is asking is that in plan view, if I have a beam like this is the plan view, and this is the web, let's say, and another beam is connected at some angle. How should the connection be done? So let's say I'm only talking about the shear connection right now. So for shear connection, what you can do is you can go for a fin plate connection in such cases. So fin plate means, see, the problem here is that the cleat, providing angular cleats like this can be challenging. Although some people do provide these kinds of cleats also, where they will make this cleat from individual plates. So instead of going for hot rolled cleats or standard angle cleats, they will go for this type of cleats made of plates. That is one way of doing it. The other way of doing it is to go for a shear fin plate connection, which means that you won't go for a cleat, but you shall go for a fin plate, which uh, which is a single plate like this, which is welded to the green beam and connected to the web of this purple beam, or even bolted to the web of this purple beam. So you can go with a fin plate connection, or you can go for the cleat that is fabricated as bent cleats. Now for the beam to column, again the same principle. Now if you want to create a beam to column moment connection, then it will be slightly problematic. So if you want to create a beam to column moment connection, suppose this is my column in plan view, and I have got beam like this connected in plan, then this will be problematic. But then I mean, you can still do it, that this will be your, let's say you are going with an extended end plate. So this is your extended end plate, and This will be problem. But then I think you can do it something like this, that you provide your bolts. You will have to set this geometry properly first in your drawing. So this will be your bolts, and then in the elevational view it will be the same as we do that. In elevational view, the same extended end plate is provided, and you are doing your boltings. Now you have to be careful with the boltings because it should properly, like this, it should properly cover. I mean, its alignment should be carefully observed and seen. So that for that you will have to, I mean, check for your actual assembly configuration, and then you provide stiffeners or whatever. So this is how a moment connection can be created for beams which are not meeting perpendicularly inclined to the column, or yeah. And for beam to beam, as I just told you, you may use the cut or bent cleat, or you may use the uh, fin type of fin plate connection. Then next question is from engineer Balaji. He's from Chennai, and he's a working professional. What he is asking: please explain about the backstay effect in tall buildings and also the upper and lower bound modification factors. So backstay, we have discussed this before also, that if this is my tower and it is connected to the podium, then what happens is that this podium level offers resistance to your lateral forces at this level. So you had a lateral force application. Now suddenly, because of increased stiffness, this podium portion offers, or these slabs may offer resistance to your lateral loads, which is good for us in fact. But then they have to be properly considered in the design of the elements over here, horizontal elements over here, and the vertical elements in your podium. You have to be properly checking for these effects, which is the resistance that will be offered by these levels, podium levels, to the tower, to the uh, lateral loads on the tower portion. So this is basically called as the backstay effect. And then your code tells you that to consider all the possibilities, you do what is called as a sensitivity analysis. Sensitivity analysis. And in the sensitivity analysis, basically, you modify the modifiers of these elements which are offering you backstay in order to get the worst results. So this, in this sensitivity analysis, you do an upper bound and lower bound check. Upper bound means you will take higher stiffness modifiers. Lower bound you means you will take lower stiffness modifiers, and whichever is the worst, you will provide accordingly. You will design these horizontal members and vertical members which are providing backstay. All these things we have discussed quite in detail in the course that we have done on tall buildings. So if you want to learn the design and detailing of tall buildings, I think this course is a very good learning resource where we explore a lot of different issues related to tall buildings as uh, as provided in the IS 16700 2023. And I think this same question was asked on the live chat, so we have covered this. Then the next question is from engineer Sudarshan Patil. If we design RCC structures for gravity load only, but not for lateral loads, then should we apply modifiers or not? Yes. For ultimate load analysis, you are still required to apply modifiers. Only as per which code? Only as per IS 16700 for the time being. So if your structure is more than 50 meters and you are supposed to design it as per 16700 then you are supposed to provide modifiers. If you are designing it as per IS 456 2000, strictly speaking, the IS 456 2000 does not have this concept of modifiers right now. So, as a designer, you're not sure whether to apply it or not because your code is not telling you anything about the modifiers. If you are using 1893, 1893 only tells you that for the lateral load analysis, it does not even talk about design. It just says for analysis corresponding to lateral loads, you are supposed to provide these modifiers. Only for analysis, that means let's say the drift check or displacement checks, only for that. So various codes right now in the Indian context are giving you different informations. Okay. So to summarize, if you are using the IS 456, as such, it does not mention anything about the modifiers. If you are using 16700, if your building is more than 50 meters tall, then even if you are doing for gravity loads, you are required to provide the stiffness modifiers. And as per 1893, I already explained the position, what you need to do. Okay. Next question is from Engineer Rishabh Thakre. He is asking about the checks for torsion irregularity. We already covered this. Then we have question from Engineer Dev Pratap Solanki. He's a working professional from Indore, and he is asking. He is asking in a PEB shed where is raft. What he is saying? Where there is a in PEB shed where is rafter is rest. I think he means there. There is a rafter resting on 10-meter column. During analysis, how do we model this with 1.5 meter RCC pedestal? Because this is where anchor bolt will rest, or model 10-meter RCC column and perform analysis. Which one is better to take complete effect? Because second becomes more critical in deflection. I'm not fully able to understand the question, but if you have a substantial length of pedestal, I mean, it's more of a column if you are saying, then it is better to model the RCC column also. If it's a column, let's say 3 meter, 4 meter long, then it is better to model the column because its stiffness and its deflections will affect the behavior of your structure. So it is better to model the RCC column also. 10 meters you are saying. Yeah. So model the RCC column. And because you are providing because you are saying that RCC column of height 10 meters is there, then no meaning of model the column up to 1.5 meter height only. Is no logic. You have to model the full height of the column. Okay, right. Then okay. Then we have the next question. Uh, Next question is from Engineer Ketan Mahajan. I am currently designing. Just a minute. I am currently designing a self-supporting roof structure, Proflex roof, which will be supported on RCC beam at 6 meters from ground. The building has arrangement of RCC structure till plinth and steel structure above plinth. I want to ask if I have to apply a horizontal thrust on column, or should I apply the loads in terms of UDL coming from self-supporting roof to steel beams, or should I do both? No, if you are getting the reaction, see, I don't know how you have been given the reactions. Let's say if you have been given the reactions as thrust in kilonewton units, you need to figure out that for a meter length of this Proflex sheet, for 1 meter length, what will be the total reaction or total thrust? Okay. So if you get that, it will be basically kilonewton per meter. Now this kilonewton per meter, you can apply it on the beam as UDL, because you are not modeling this Proflex sheet. So it is better to apply it on the beam, because that is how the load transfer will take place. The Proflex sheet is resting on beam and beam is resting on columns at every whatever distance you have got between the column center to center. So it is better to apply the loads to beams first. Uh, Now that load you may apply it as kilonewton per meter units. For that you need to observe how the reactions have been given, for what length of this shed have they given the reactions. So it will be generally mentioned in your output report that you get from these roof suppliers, that for what length of this Proflex sheet piece have the reactions been given. Accordingly find out the kilonewton per meter and then apply it as UDL on the beams. So the most appropriate way will be to apply it as UDL on the beams, and UDL also in the lateral direction. Yeah, yeah, he has shared one image also. So that's what I'm saying. You apply the UDL on this beam that is going along the length, this beam. You apply the UDL on this beam, and then from there it will get transferred to the column. So do it like this. Okay, very nice. Then we have the next query. What is the next query? Okay, so these were the queries asked on the Google form. Now let us take the queries that have been put on the email. So Mr. Vasu Badania is asking, he has shared this image and he is asking, hello sir, how can we create beam girders? How can we create a beam girder or column with stiffness plates in between in ETABS, STAT and Idea Statica? So in Idea Statica, there are modeling options available which you can use to model the stiffeners. I cannot show it online in the live session like this, but there are modeling options that you can use for creating the stiffener plates. Instead, you have the option to define the TST and TSP, which is the presence of transfer stiffeners and spacing of transfer stiffeners. Accordingly, it will calculate the shear strength of the web depending on the stiffeners provided and their spacing. In ETABS, you do not have any option of defining stiffeners to the webs. So those calculations have to be done manually. Okay. ETABS gives you no option to do it. Understood? Okay, so this was Engineer Vasu with his question. Vasu with his question. Now there is no further question on the email. So I think let us take the questions from the live audience now. So all these queries we have already taken. So we are taking the query from the live audience. Engineer Venkatesh, is it advisable to release the torsional modifiers to 0.00 triple what how many double zero one for the beam and designing the slab using Excel sheet? Do we need to consider any torsional moment for the slab design or not? The torsional moment to slab or torsional moment to the beams? Your slab is resting on the beams. So if you have the system as compatibility torsion, if you have the system as compatibility torsion, as per the Indian code, you can do this that you assign a very, very small modifier, a very small torsion modifier to the beams, because of which what can happen? What will happen? That this torsion resistance will be very low, because of which the slab movements will increase, and then you design this slab for increased movements. So that you can do. Okay, that you can do, assuming that the case is of compatibility torsion. You're allowed to do that. If you look at the ACI code, there it says that if you have the case of compatibility torsion, then you may apply torsional modifiers to the beams, but then you have to design the beams at least for the threshold torsion value. So you apply a modifier in such a way that the beams have torsion value equal to threshold torsion, and for any value higher than the threshold torsion, let the slab take those torsion as bending moments. So this is what your ACI code tells you. No such provision is there in the Indian code. So as per the Indian code, if you have the case of compatibility torsion, you may put small modifier values, very small modifier values, so that their torsion is almost negligible, and then design your slab for increased moments. All right. So this was the query from Engineer Venkatesh. So we have taken all the queries from the live audience. We have taken all the queries from email. We have taken all the queries from WhatsApp as well, and Google Form also. So is there anything else? Any further query? Any further question? Do we provide torsional reinforcement at the ends? Yes, the code wants you to provide torsional reinforcement at discontinuous edges. At corners where two discontinuous edges are meeting, you have to provide the reinforcement which is given in the code. On those edges where one of the edges on a discontinuous, uh, uh, one of the edges are discontinuous, you provide half of the torsional reinforcement you have provided at a corner which is where two discontinuous edges are meeting. So if this provided reinforcement was AST, you provide over here AST upon 2, half of the reinforcement. And then the calculations and requirements are given to you in the design SP. So you may read SP34 for details. Yes. Anything else? So I think that's it then for this session. We have taken up all the queries. Now you may continue to put the queries in the same Google form, as you all know by now. The the link for the Google form remains the same. So you may keep putting the queries throughout the week, and once when we meet every weekend, we take up your queries. So this is the link to the Google form. I am just putting in the live comments. And if you want to connect with us on WhatsApp, you may click on this link. Okay, wait a minute. Mr. Harish Acharya is asking how to design water tank using LSM method. You may refer IS 3370 2021. So these codes have been revised and they have been updated for the LSM based method. We have done a complete course on the liquid retaining structures based on the LSM method, which includes the detailed understanding of these codes, calculation for hydrodynamic loads, applications, checking for different limit states, all those things we have done. So perhaps you may be interested in having a look at that course, uh, liquid retaining structures course. Okay, right. Yes. So I was telling you, if you want to connect with us on WhatsApp, this is the link, and you can just click and send a message to us on WhatsApp. So I think this is all what we have for this week then. Thank you very much and see you next week now. You may continue to put your queries in the same Google form as mentioned. Mr. Harish is adding how to calculate the depth. Yeah, so that's what I said. It's not possible for me to explain it on a session like this because you need to understand the different limit states first, how to calculate, how to check for shear, how to check for crack width, how to check for flexure. Then there are some minimum guidelines required by the code, uh, how to do all those things. It is not possible to discuss it in a session like this. So maybe you can go to the books if you wish, or as I told you, we have done a very good course on liquid retaining structures. Maybe you can have a look at that. All right, so that's all for this session then. Thank you very much, and we shall see you in the next session now. And thanks to everyone for joining. Have a good weekend, and bye bye.